Let's start with a basic example. Consider if I tell you that the President of the United States, Barack Obama, died in 1850. Obviously, you will not believe me. But if I tell you the same thing thousands of times, you still would not believe me because you know when Barack Obama was born. This does not mean that you did not learn anything from this data. Yes, you learned that you received wrong information most of the time. Your memory was updated with the fact that you got a lot of incorrect information. You know it is not possible for him to have died earlier than he was born, as you already know about his life and how time works. Additionally, there are other factors in your brain that help you critically evaluate everything you receive from your surroundings, but that is not the case with LLMs. Now, what if we do the same thing with LLMs? If we tell them that the President of the United States, Barack Obama, was born in 1850 thousands of times. By this, I mean we feed this sentence during training, then it will update its weights based on this incorrect information, and thus the LLM will start to believe it. This is because LLMs receive information as it is without truly understanding it, and their goal is to memorize the data. By memory, I mean their objective is to store all the data fed to them, approximately. Remember, we discussed a simple example where the goal of a neural network was to store information. We trained a simple network that was able to store approximate answers to much larger data with just two weights. Here, to store data, we can see that the neural network must follow some pattern. In this case, the pattern of inputs can be learned with just a linear function. And now, just by using inputs, we can get approximate answers to the stored data. The same is the case with LLMs. LLMs try to learn all the data we feed to them using next word prediction techniques. And in the process of learning, they develop relationships between words and their usage in sentences. Remember in the previous video, I mentioned that embeddings are just representations of each word's relationship to other words based on their use in text. When I say relationship, I mean that each embedding value is interpreted by the LLM in the same way, depending on its magnitude. And this applies to all other values in the embedding as well. If we explore a little further, let's say we want LLMs to understand the word time. For LLMs to understand this word, they will look at how it is used in different contexts, and this will also be influenced by how other words are used in various contexts, extending to the entire dataset and vocabulary. But does that mean the model truly understands the meaning of each word? Let's say they represent the meaning of each word. The problem is that we interpret these embeddings as the meaning of each word and claim that these embeddings actually represent the meaning. In reality, LLMs do not understand the meaning of any of these words. I know you might be a bit confused by what I just said, but I will explain this at the end. Now, there are two outcomes. First, LLMs have an understanding of the words in the embeddings. Second, LLMs do not have an understanding of those words, but we interpret them as their meaning. Before jumping into the main part, let's try to define the word intelligence a bit. Here, we do not want to enter into a philosophical debate about what intelligence is. I asked this question on Instagram, and many people answered, some with philosophical responses and others with abstract ones. But our main goal is not to universally define intelligence. As scientists, our objective is to solve problems in this world and make AI think like humans in order to address the problem of critical thinking we mentioned at the start of our video. To explain this, consider two scenarios. The first is a simple Python function to add two numbers, and in the second, we develop a neural network that takes two numbers and adds them. But now, let's say this network consists of two weights and zero bias, where the weights are 1. This is a representation of the neural network function, but you can see that these are essentially the same functions, with one function multiplying these two numbers by some value and then adding them. The question here is, what is the difference between these two functions? Does making this simple neural network more complex make it intelligent? In reality, we randomly initialize these weights first, and then the model learns to solve the problem through weight updates. Both are solving a problem, so let's say intelligence is figuring out a way to solve the problem. So in this case, for now, neural networks are intelligent. We will further refine this concept of intelligence later. Let's say LLMs are intelligent, and we want to figure out how intelligent they are. Consider that we want to approximate a function, and this function represents human intelligence. We have human data, which is almost accurate. Now, we train the model on this data, and you can see that this portion can be accurately approximated, allowing us to get answers to questions that are not present in the dataset. But remember, outside of this function, you won't get accurate results after moving a little beyond the area where the data is provided. Now let's say we have some additional data. The approximation becomes better on the other side as well, but it's only by a small margin, which is negligible compared to the dataset we feed the model. The point here is that outside this data, you will not get accurate answers. For instance, if you ask ChatGPT about some new research that occurred before it was developed, or ask AI to figure out groundbreaking research innovations, you won't get anything useful. However, you will get accurate answers for things that are already present on the internet without needing to search for them, which makes ChatGPT useful. Linking to the previous part, consider feeding all the data of science that existed before Einstein was born and expecting ChatGPT to give us the theory of relativity. Well, that's not possible. But we can ask LLMs questions that are similar to problems already present in the dataset. GPT is a way to store data and retrieve that data with prompts, even for questions similar to the stored data, with very little generalization to answer completely new questions and problems. We could say it's a modern data storage technique, functioning somewhat like Google if we focus only on data storage. Imagine you have a question about an error in your data, and you feed a prompt to ChatGPT. If ChatGPT has been trained on data involving similar problems to the one you're facing, it will return an answer based on that data. This is quite useful. This is how far intelligence can go, right? Let's ignore the new model trained on RL for reasoning by OpenAI for a moment and focus on traditional LLMs. Remember, these LLMs are kind of databases. They store huge amounts of data, and you try to retrieve relevant data using prompts. When you ask ChatGPT, "Who are you?" and it replies, "I am an LLM named ChatGPT," that does not mean it has some kind of personality. It's just a layer over that database that pretends as if this LLM has a personality. We all instruct this database not to answer questions on sensitive topics. But remember, it's not a personality. It's just like talking to a database. What do you think? Are LLMs just a way to store large amounts of data using neural networks, with transformers being better algorithms to accomplish this? Now to the main point. We discussed earlier that LLMs do not understand human language. By this, I mean that when you use the word up, LLMs do not have any understanding of the word up like humans do, and the same applies to other words and different movements, and so on. Now remember, I'm not talking about consciousness or emotions. I mean that even if LLMs do not understand emotions, they should at least know how a person behaves or reacts in the real world if that person has such feelings. You know what? We have already developed a way to teach neural networks the actual language. Remember reinforcement learning agents in some adversarial setting? These agents communicate with each other, starting with random messages and then slowly developing a language. The difference between those RL agents and LLMs is that these RL agents have ideas and plans in their environments, and they want to communicate those ideas with other agents using some encoding. This encoding is actually the real language. In language, we first have some ideas or thoughts, and we try to encode them in words, embeddings, or anything else. But the problem with LLMs is that they have never seen the real world. What I mean by this is that you cannot understand a fourth-dimensional object without actually observing it with some sense. You might say, but I can infer it using 3 dimensions. However, remember that LLMs are not interacting with a single dimension, so how can we expect them to understand a 3D world and its language? Remember, RL agents that are actually performing in the real world or in similar virtual environments can understand the language they have developed. When we map this agent from a virtual environment to the real world, it understands the language it developed. This language is simply a means of communication to achieve its objectives based on rewards, but at least it is developing some form of language. Now, what was the goal of language development? Remember that animals have language for their own goals and also communicate, but unlike LLMs, RL agents, humans, and animals have an understanding of what they say. Although this language is not a high-level language like human language, imagine if RL agents could speak English in the real sense. Don't you think that in the future, they could critically evaluate the language and build their own knowledge? But how do we teach AI about time? I mean, what is time? There is a solution for this, and that is that Markov decision processes in reinforcement learning can be used to teach AI the concept of time. Remember, if we develop an agent with senses like vision, hearing, and some sense of time, like MDPs, we can feed the agent a state, and then the model performs an action. This can help the model develop some sense of the real world, just like humans do. And with a reward function, we can ask the agent to solve certain problems. Imagine an AI agent that understands human language and the real world, then tries to solve a research problem related to geopolitics. It could use information from computers, which it can evaluate like humans. But unlike humans, it can learn a vast amount of data in a very short time and even critically evaluate that data. With this information, it could come up with solutions that even humans cannot, just like the AlphaGo game by DeepMind. There are a few problems in neural networks right now. One is continuous learning. In continuous learning, we cannot update model weights continuously because the model faces issues like catastrophic forgetting, and its weights slowly fail to learn new data after some time of training. The LLMs we use today actually do not learn continuously from interactions with users online. They are first trained and then used as static models, like functions. I mean, when you are interacting with ChatGPT, it works as a function with static weights to give you answers, while humans do not operate like that. They learn from every interaction. One more problem is that if we develop an AI that interacts with the world, it is not possible to teach that agent to learn language like humans do. RL agents are currently quite weak for such tasks. Remember, we said intelligence is the ability to figure out a solution to a problem. But what are the problems that LLMs are solving? These models are primarily designed to solve the problem of storing data using next word prediction. Instead of supervised next word prediction, we should develop models for goal-oriented problem solving, similar to what we do in reinforcement learning. We already know that if we can map any problem to MDPs, we can somehow figure out a way to solve it. The new model by OpenAI might be using this technique to develop some level of intelligence because they claim that they are using reinforcement learning for reasoning in the latest LLMs. However, to what extent can we increase the intelligence of LLMs without letting them interact with the real world? I mean, there are limitations regarding computation and also data. But remember, our main problem is to critically evaluate the data a model receives. What I am trying to say is that the model should not be dependent on which data it received and how many times it received that data. It should also understand and check whether it should accept something as a fact, fiction, or a lie. In unsupervised learning, every sentence is treated equally as a fact by the model, depending on how many times that fact appears in the data. We want LLMs to learn from the data, but they are actually learning the data. However, if LLMs started doing this, then this is the point where LLMs could develop their own personality, where we can only control them through some kind of reward. If we decided reward incorrectly, it can be very dangerous. Assumption is that as we move from supervised next word prediction to actual AI with the ability to think critically, I believe we will see a slowdown, just like in programming languages. Moving from assembly to Python tends to get slower. If you don't agree, I would suggest looking at RL agents. I mean, they are much slower and more unstable compared to supervised techniques. At the end, I would say that if you want to have a discussion about this video, feel free to join our Discord server for some healthy discussion on the topic. This Discord server is dedicated to discussing the future of AI, especially the development of AGI in the coming years.